Up next, we have CoatChecker from Zurich, Switzerland, ZHAW, Zurich University of Applied Sciences.
Hello. I'm Alexander from CoatChecker, and this is our device. We have filed a patent for it, and now we are here seeking financial support to bring it to market. I'm here with my two co-inventors, Joris and Nusret, and as we begin, I'd like to show you some pictures of buildings or bridges you might have seen on the journey here today. The Lane Stadium, home of the Hokies, or these bridges on the highway. I bet next time you're riding the highway or enjoying a football game, you don't want this to happen. Many of these pictures have one thing in common: damaged ceiling layers. Why did nobody notice it before these accidents happened? Because many of these bridges, the ceiling layers are not tested correctly, or not at all. But so why not do a proper job? Because it is very time-consuming, tedious, as well as costly. And if you do it today, it is a bad idea anyway. And Joris is going to show you why. The problem is that today's measuring techniques are so outdated. Companies still drill holes into freshly applied sealant to make sure it's thick enough. Aren't they crazy? In addition, over the years, these tests have to be repeated to make sure the sealant is still thick enough to shield the concrete or the steel from weather damage. Afterwards, they insert a needle to measure the depth of the hole. You can imagine this destructive method uses a lot of time of your workers and your money. After measuring, the drilled holes have to be resealed. Again, this takes time and money. And these resealed holes represent a serious weak spot in the whole coating shield. In addition, these holes look hideous. Like Swiss cheese, right? Because resealing these holes would take too much time. We will skip right next to the solution. We don't make Swiss cheese. With CoatChecker, there is no destructive testing going on. Gentle heat will treat the sealing layer. CoatChecker then takes a reading from the surface and analyzes it. And from that analysis, we then can relate to the exact thickness of that corresponding sealing layer. The idea for this method, for this non-destructive method, was developed in cooperation with our advisor, Dr. Professor Niels Reinke, who is an industry expert with over 20 years of experience in contactless, non-destructive measuring coatings. With his assistance, we filed a patent protecting our new device as well as the new method. We chose the bridge construction sector as an entry market, as it requires a high quality because of safety reasons. The reduced measuring time will enable officials to make their mandatory yearly safety checks quicker and allow for shorter time for the bridges to be closed for a shorter time. The American Road and Transportation Association says that by 2020, over $332 billion have to be spent in bridge repair investments. So that would leave us with a $45 million market based on the sealant sold in 2015. We put together a business case for the Chesapeake Bay Bridge up in Virginia Beach. The bridge spans over 4.4 million square feet, which is about 76 American football fields. Because you take 20 measurements in an area of 1,000 square feet, it takes about 88,000 measurements to measure the bridge one time completely. For these 88,000 measurements, the today's destructive method would use 5 whole years to be completed by one person, and they don't get any holidays. With CoatChecker, it would take only a quarter of a year. This results in a 20 times faster as well as cheaper, non-destructive way to measure ceiling layers. Because we can measure all sorts of ceiling materials, one of our next potential markets would be the commercial construction sector. In 2016, over $700 billion are being spent on new buildings. We estimate that roof sealant alone would give us a $50 million market. In addition, there are many other potential markets. For example, shipbuilding or offshore wind turbine protection coatings, etc. There are many more. We have some competitors on the world. For example, a company that measures with ultrasonic sound, but their method needs a sender and a receiver on opposite sides, so have fun with that on concrete bridges. There are other companies that measures paint. Their method works in the micrometer area, in the micrometer range, but the sealant we use, they're in the millimeter area where their method doesn't work. If they can measure thicker layers, they're confined to conductive materials, which would limit their field of appliances severely. Our presentation is based on the European business model, because that's where we begin selling. In the EU, we will make money by selling our device and charging a yearly licensing fee. This will give us recurring income. For the licensing fee, we will provide database updates as well as replacement parts. Our ultimate market is the United States, so that's why we show US figures. We are committed to have the product ready to be tested with a selected partner in the third quarter of 2017. In the second quarter of 2018, we will start sales to our target customers. Our team consists of 3 system engineers graduated from the Zurich University of Applied Sciences. Nusret, who is in charge of all the electrical engineering. Joris, responsible for product design and development. And myself, I'm doing the software engineering. And also Professor Dr. Nils Reinke, acting as our senior advisor, who is already a successful entrepreneur. Our finance forecast looks as follows. The device costs $500 to produce. We will sell the device for $2,000 with a yearly licensing fee of $2,500. In 2017, we plan to additionally hire employees to help with product design. In 2018, to meet the increased demand, we will hire additional workers, and break-even is expected to happen in 2019. Until 2021, we'll have 15 employees and an income forecast of about $21 million. At that time, free cash flow will rise to $32 million. We want $500,000 for 10% of the company, and we'll need $300,000 to reach milestone 1. We will spend the money on facilities, product certification, and prototype pre-production. In a second phase, after reaching milestone 1, we want the remaining $200,000 to increase production and sales, as well as marketing. Thank you very much for listening. And if you have any questions, we are happy to answer.
I'm just not sure I understand the technology. Did I hear you say heat? The main
Heat.
Okay.
So can you maybe just elaborate on that? So the higher the temperature, the thicker the The higher the temperature, the thicker the coating?
It's a little bit more elaborate than that, but basically, we can, after you calibrate, you're able to see a clear difference between the temperatures.
Okay. So my question really has to do with penetration of the market. So you sort of described the size of the market, but and you're using the word sealants. So I'm assuming any coating, paint, are there particular types of coatings that are used currently in the United States that this would not be effective on? So let's say I have a bridge, and it's my job to make sure the bridge doesn't rust, and I choose to put paint on that bridge. Would this work, or would it not work?
Yeah, it would work.
Okay. Talk to us about the licensing fee. So what is the useful life of the product, and how does the licensing fee work? It's an annual charge of $2,000, you said? Is that right?
Yes. That's correct, yeah.
So who are you licensing it to? Who's paying that?
So the licensing fee is being paid by the companies who also buy the product. So the building companies who actually need to measure the sealant layers. So after applying it.
So it's not the government, it's a contract.
Yeah, but there are also governments who need to buy because they need to do their mandatory safety checks.
Yeah, I'd follow up with, what is the standard practice now for checking bridges and making sure they're secure? Who's responsible, and how often do they do it, and that sort of thing?
So in Switzerland, there is the government institution, like the regional commune, who is responsible for a yearly safety check on these bridges, because there are sealants on the bridge, and as cars drive over it, it gets used up. So they have to make sure every year it's checked.
Two questions. One, is there a correlation between your readings and a predictive capability to be able to prioritize which bridges, for example, should be reconstructed or dealt with first? Because one of the issues in the U.S. is we all know that there's a deferred maintenance problem on roads and bridges, but there's a big difference between being able to identify $300 and some odd billion and when that money gets released. So they've got to release those dollars against the highest priorities. And so I'm wondering whether you have a vision or whether you have a capability currently to say, if I finish, say, the Bay Bridge Tunnel and my readings come back showing, this range, would that create a red zone problem as opposed to a yellow light kind of a problem that could be used by those allocating budgets to prioritize which bridges gets worked on first?
Thank you for the question. Just a second. So, we understand. Well, I did. That's basically up to the government institutions. It's programmable, but normally we would leave these safety zones up to the government.
I have a question. So this device is just for measuring the thickness of the ceiling around the concrete, correct?
Yes.
Is that the primary means that these bridges fail because the ceiling has inadequate thickness?
This is one of the reasons, not the primary one.
So this only addresses this one particular problem. So what are is that the main problem? Or I'm trying to understand how big this ceiling thickness is as a problem. Or are there other problems that are more important?
It's one of the bigger ones.
Okay, so like what are the things that are, that do these people who do these annual checks, what do they have to do besides just measure ceiling?
Well, we know about the sealants,
Right.
but of course, there are different problems to bridges, like stability problems or beams get tired.
Yeah. Okay. Yeah, just general metal. I would think that those, in some ways, these other ones are in some ways more important, but I'm not familiar with the practices or the technology. But I'm still trying to understand your technology. So you heat up the sealant.
Exactly, yeah.
And then how does it measure the thickness?
Because we measured, I don't want to go too much into detail because we filed the patent. So, because we measured the temperature, there is a difference between the different thicknesses of the sealants. So you can gather from the curve what are you dealing with, which thickness you're dealing with.
And have you made any kind of like measurements using the manual technique and this to see how accurate it is?
The thing is, the device has to be calibrated first to a very specific thickness. So you can say, oh, okay, this is 1 millimeter or 2 millimeters, and you calibrate the device for an hour, and then afterwards you're good to go.
I see. Okay. All right. There's some questions from the audience. It looks like there's a competitor, Olympus-IMS, already has this for multiple thickness. How is this different than what's already out there?
They use their device on conductive material, as far as I know. So that wouldn't work on just concrete.
I see. So if it works on infrared, what happens during hot summer days when you can't distinguish between different sources of infrared radiation?
The thing is, we are making like some sort of isolated area, so we can either cool it down or heat it up more as we need.
Okay. And does it work on all types of materials?
Yes.
So what types of materials have you tested it on?
Ceramics, filler materials, like on the outside of bridges, then liquid plastics in general.
So those are the
wood,
common.
we tested it on wood.
So those are the common types of sealers that are out there.
Yes.
Okay. All right. And okay.
I was going to ask about the functionality of the shape of the device, and why is that shaped like that? Or have you thought of something else? Or even something you could, if it's steel, using magnets, I don't know.
Yeah, it's just because to get it nicer. Because inside it looks as a prototype, and so we thought we were going to make a shape around it that it looks like prettier. Yes.
To add that, that's not a final design. This is a pre-prototype design. So.
Okay. One more. Okay. So is this your professor's idea, and is it now owned by the university, and you've licensed it?
No, this is our idea, and yeah, pretty much.
So the patent is filed under your name, or?
Well, the patent is filed under our name, but the university owns it because we were part of that. We have a backup slide for that, but we are in talks with the university to get it transferred over.
Very good. Yeah, good.
No, there are normally from. Can you see that? Yeah, there we go. Normally from experience, there is very, very little royalty or licensing fee, even no licensing fee at all. So, yeah, we are in talks to get it to our company. Exclusively, yeah.